Hi. Well, in this video, what we are going to do is to examine a time diagram of a mealy machine. So this is also an analysis in which you can see t, time, as an independent variable. In the previous analysis, the analysis that we have done by using the mathematical model state or state table or state diagram, they do not have time in it. Now this one is going to have the time. So this is a state diagram of a mealy machine. Now to analyze this uh, mealy machine including the time is called time diagram. So name is time diagram. At the end, we will see the difference between the mealy machine and Moore machine in terms of time diagram, and the problems that we are going to face in mealy machine is going to seen in this example. Now, to draw a time diagram for a mealy machine, we need the variables, input variables first. So what could that be? Could be one of them is input, isn't it? In order to detect the input, we need a clock pulse. You know, sequential machines that we are examining in this course, they are all synchronous. That means there is a central clock. So this is clock. Here, this x is time. So this is time as well. So I will name them later on. So as I said, this is x, this is clock, and we've got independent variables small y and the dependent ones capital Y's. So since we've got two memory elements, we've got two of those. I'm going to name them right now. Okay. And the last one, not least, is the z output function. So this one. So let me repeat, let me name them all. So that is x, and that is clock. That is y1, at the same time y2, at the same time y1, y2, small y1, capital Y1. What it means, the small y1 is the present state representation. The capital Y1 is the next state representation. So this small y1 before clock pulse, the capital Y1 is after clock pulse. Okay, this one is Y2 and capital Y2, and that is Z output. So there is one Z output, that's YZ. If there are two outputs, so it's going to be two Z1, Z2 is drawn here. So in this axis, this is the variable that we are going to see. See the time. That's why we call this time diagram. So let's say choose any input sequence. So let's choose this input sequence like this. Maybe that should be black as well. So that is 0. That is 1. That is 0 again. That is 1 again. 0 again. And 1 again. So our input sequence is 0, 1, 0, 1, 0, 1. So in order to detect these inputs by the mealy machine, for each input bit, I need a clock pulse. Otherwise, you cannot accept this input as a procedurable input. So there's going to be a clock pulse for this 0 input, another clock pulse for this 1 input, another clock pulse for this 0 input, another clock pulse for this 1 input, and a clock pulse for this 0, this 0, and one for this clock pulse. Assume that these memory elements edge sensitive ones, and they are on the negative edge sensitive ones. So that is going to be this edge. Memory elements are going to work. In other time intervals, they are not going to work. So this is input. That is how this input is accepted by the circuit. And this one is at the beginning, since we've got 4 different states here, 0, 0, 0, 1, 1, 1, 1, 0. These are the 4 states. At the beginning, before the first clock pulse applied, I am going to start from a state. So this state is called the initial state. So assume that initial state is 0, 0, 0. So that initial state for this clock, it is present state. Now I am going to draw this small y1 and capital Y's changes first, and then I am going to find the Z output. So for the mealy machine, it should be done in this order. I will explain later on why it should be done in this order. Now, since our memory elements are negative edge sensitive memory elements, the state change for these memory elements is going to happen on this negative edge only. Let me draw that instant. So I will draw this instant. Let's say it is, that color, okay? So the change should be on this edge. You see that? Negative edge. And for this one, at this edge, change is going to happen. State change is going to happen. For this one, it's going to be this one. Made a mistake. That move a bit. So I'm going to correct it a bit. You see, this is not a straight line. That's why it is critical. I would like to correct it. Maybe this one as well. Okay. I'm going to draw this back again. Okay. Now what I am saying is this. That is the negative edge. Maybe this one. That is the one. And for this one, it is this. And for this one, it is this. Now I'm going to recorrect it later on. Okay. Okay. Now, the state changes is going to happen to these red instants, right? Okay. For the input, when the input comes, there's going to be Z output changes, and that's going to happen when the input changes. So another change instant is this input change. So I draw the input change as in green color. So that's green color. Input change happens on this instant. Another instant for the input change. This is another input change. Anyway, this is another input change here. And this is input change, another one here. Okay. Now I will be using an information about the critical time. That time interval here that I show is critical time interval. I will explain why it is critical right now. So this time interval I am talking about between the red and the green one. Here you are, and here you are. So in this time interval, my input is 0. For this critical time interval, my input is 1. For this, my input is 0. For this one, it is 1 here. And for this one, 0 here. And for this one, it is 1, isn't it? Now, let's come back now. And for this input, what's going to be the state changes? Let me draw it now. Since it says at the beginning or initial state is 0, 0, so I am here in this state. So the clock pulse comes when the input is 0. Clock pulse comes at that state when the input is 0. That's this one. My next state is 0, 1. So I draw that my next state 0. That's going to be 0, y1. And that's going to be 1. So this blue one now I am drawing. If you pay attention, you see now when I have a state change, this change stay as it is until the next clock pulse comes. Why is that? Because we said our memory elements works for the edge sensitive. On the negative edge it works. In the other time intervals it's not going to change at all. It doesn't work. So that's why I draw that line until the next clock pulse negative edge. So that's 0. So that is 0 as well. And that is 1. And that's 1 as well. So I have a change here. This change stays as it is until the next clock pulse comes. So I am in this state now. So the next state I came, the second state was this. So for this state is 0, 1 state. My input is 1. As you see negative edge, my input is 1. So on this state, I have got my input 1. Input 1 is this, isn't it? So what's going to be my next state is going to be 1, 1. So I'm going to draw this 1, 1. So y1 is going to be 1. And y2 is also going to be 1. So that's going to be 1, 1 in this time interval. In this critical time interval, it is 1 again. So I came to this state now. Now on this state, I have got input 0. So in this state, I have got input 0, that input. So my next state is 1, 0. So y1 is going to be 1. That means continue as 1. And it's going to be 0 for the negative, for the second next state function, isn't it? That's 0. So that's going to be 0 on this edge. So it goes up to here, sorry, it's just here. 0 here, 0 here. So 1, 0 state. We are now in this state, 1, 0. 4 nodes. This is the fourth state that we are in. So I am in this 1, 0 state. My input is 1. You see on this negative edge, the input is 1. So in this state, I am going to have this 1. So my output is going to be 1, and my next state is going to be 0, 1. So this is going to come down, and it's going to be 0 until the next state changed. 0, 0 here, and 0, 1. The second state variable is going to become 1 until the next edge. So 1, 1 here. So in this state, so that's the fifth state. 1, 2, 3, 4, 5 states. fifth state. On this state, I have got input 0. When input is 0, that means you come back to that 0, 0 state. That is the sixth state. 1, 2, 3, 4, 5, 6. Okay, 0, 0. So that 0 is going to continue until the next state change. And that's going to be 1, 1, 1. And that's in between is 0. You see, this is how the state changes. So in general, you can say that state changes happens on this negative edge only. You see here, state change. Here, state change. Here, state change. Let me show it with this one. So here, negative edge, you see state changes. So negative edge here, state changes. So the red one. And the negative edge here, state changes. So the next thing that we're going to do is draw the Z output. The difference between states and the Z output function is this. State variables are going to change on the negative edge of the clock pulse because these are the outputs of memory elements. Memory elements works with clock. Now Z is the output of a combinational circuit, and this combinational circuit does not work with clock. There is no clock input in the combinational part. So therefore, Z output is going to be drawn just by looking at the present state and the input. So let's do it now. So that was the beginning, was this, isn't it? So in this state, you are applying 0, your output is 0 here. Before clock pulse, you're going to see that set value. Why is that? Because the combinational circuit. If you know the present state, if you know the input, that is the output. That output is the output of a combination circuit. Therefore, before the clock pulse, you're going to see that output. So that output is going to be 0 until the clock pulse is going to be 0. When the clock pulse comes, let's examine the situation now. My input is 0, my present state is 0, 1. So that's second state. On that state, 0, 1 state, my input is 0. So in this state, my input is 0. I'm going to observe this output, second output. Okay, so this output is 1. I draw in this critical time interval, my output is 1. So what happened in this time interval, this green one and this red one? My input, my present state is 0, 1, that is this one, and my input is 1. In that state, my input is 1, that's the one. So my output is going to be this one. So this one I'm going to observe, third one. In here, it's going to be 0. Okay. So in this critical time interval, my state is 1, 1, and my input is 1. My state 1, 1, my input is 1, my output is that 1. So I have got 1 here. So I am in this state now, 1, 1 state, and my input is 0. In this state, if my input is 0, that's going to be my output. So this is the fourth output, 1, 2, 3, 4. So in this state, when you apply 0, that's going to be the fifth output. And it is 1, isn't it? So in this time interval, my output is 1. So in this critical time interval, my present state is 1, 0. That's this state. On this state, we are applying 0. On this state, we are applying 0. That is the output that I am going to observe. So that is the sixth output, isn't it? That was the fifth. So that is the sixth. So in this critical time interval, I am going to have a 0 value. Okay. Now if you look at this one now, my present state is 1, 0. We are applying 1. 1, 0 state, you're applying 1. So that's going to be my output. 7th output 1. In this time interval, 1, 0, 1, this time interval is not. So that's going to be 1 here. So I'm going to stop here because that information is enough for me to give you an explanation about the mealy machine output. So if you look at here, we've got a 1 between two zeros. If you look at here, there is a 0 in between two ones. So in this critical time interval, what is this critical time interval? Let me explain it, what it is first. So this is what happens if there is a state change here. When you come for this clock pulse, that is your present state, that's the next state. So when you come to this next state, your input, which is applied for the previous state, is still there. So when your state changes, you've got to change the input, but we cannot do it. Still, we've got the previous input until input changes. So in between, my state change, but my input hasn't changed, stay as it is as previous input. In this case, what happened is an output that I don't want to see. Why is that? Because my expectation is this. There is a state, you apply an input, you come to a new state, next state that is, you're going to apply a new input. But we cannot do it. We came to a new state, still we've got the previous input. So that is the trivial time interval we're going to see. So this time interval is not the one that we would like to see. So this is unexpected output here. So unexpected output here means there shouldn't be that one, because you could, maybe you are controlling with this circuit, you are controlled to run a machine or whatever, something else. Let's say elevator you are running with this output. So this unwanted, unexpected one output means elevator is going to work. But I do not want to work with it. I would like to see these two, because I couldn't apply the input at the right time. So therefore, this is a fault area, fault output area, and this fault output is very critical because unexpected one means unexpected run of my circuit. That's why it is called one hazardous output. So if you look at this one now, it's not like that. This one is not in between two different zeros. So this one, normally this one is your expectation. So you are observing this one a bit earlier. That means in time interval, let's say in milliseconds, you're going to observe your output a bit earlier. If it is not very critical for you to run the circuit, so you might say this is a false output, but it is not hazardous. So this zero is different because this zero is in between two ones. Therefore, it is a hazardous zero. So you could continue on this like that. So a new problem came in now. There is an output, unexpected and hazardous output. How we can get rid of from this hazardous output? Now, the solution to this engineering problem is to put a delay element at this output. So let's say you've got a box here and you've got Z output here, and you're going to apply, this input is going to transfer the D and D output. So if there's a clock to run this circuit is this circuit, you see? I put it in a box. So this works with a clock pulse on negative edge. Clock. So this clock also connected to that D memory element. This is negative edge again. So you've got the input here, right? So when this clock pulse comes, this information, according to the input and present state, you're going to Z here. Okay, you're going to have this Z here for the first clock pulse. This is first clock pulse. So for this first clock pulse, this is not going to work because at this instant there is a time delay here and this Z comes. So this set is not transferred to the output of D. You see the D definition relation is this. So input is transferred to the output. You cannot transfer that Z to the output with this first clock because the Z takes time to move from here to here. In this time, this is earlier came here, that's clock pulse. So this is not transferring this Z value to here. Z came after the first edge. So when you apply the second edge, so that means instantly that edge is going to be the same here. That's the first one, that's the second one. So in this time, this Z value is going to be transferred to here. Now what happens is this here. You see the unexpected outputs, which includes the hazardous ones, they are seen after the clock pulse. So before the clock pulse, I am observing all the right outputs. So before the clock pulse, that's the right output. Before the clock pulse, it's the right output, right output. It goes like that. So that means before the clock pulse, I am observing the right output, isn't it? So this here now, for the first clock pulse, this is not transferred this one to here. When the clock pulse comes, the Z value before the clock pulse is transferred to the output. So always I am transferring the accepted or real outputs. I said real outputs. I mean no false outputs. That means no faulty outputs, hazardous or not, output are seen here because I am transferring the Z information just before the clock pulse to here. So that is the solution to that mealy machine problem that we faced. That is the end of this video then.